There is a space-age dust sitting on Amazon right now for under $10. It has a friction coefficient so low that scientists have no better number to measure it. NASA uses it on Mars rovers because nothing else survives the conditions. The United States military coats precision rifle components with it before classified operations. Formula One engineers pack it into engine bearings that must survive without a single drop of oil. And right now, that same dust will make every knife, axe, hinge, firearm, and mechanical part you own virtually indestructible for the rest of your life from one single application. No re-oiling, no maintenance, no monthly purchase. You apply it once, and the metal remembers it forever. The global lubricant industry generates over $166 billion every single year, selling you bottles that run dry, attract dirt, freeze solid in winter, and evaporate in summer heat. A $10 powder that replaces every bottle you will ever buy cannot be allowed to spread. And for decades, it did not. This is the story of tungsten disulfide, the forgotten space lubricant that the lubrication industry has spent 40 years making sure you would never hear about. Welcome to Lost Skills. This is where we open the vaults. Subscribe and hit the bell so you never miss what gets buried next. Let me tell you what happens when your lubricant fails in the wild. The temperature drops to -20 overnight. Your folding knife stiffens until the blade will not open with 2 hands. Your rifle bolt drags instead of cycling clean. The pulley on your camp system locks under load. In that moment, the WD-40 in your bag is not your problem. The problem is that WD-40 was never designed for that moment at all. Cold thickens wet lubricants into paste. Heat thins them until they drain away entirely. Dust, sand, and carbon bond to their wet surface like a magnet and build into grinding paste that accelerates the very wear they were supposed to prevent. Every experienced bushcrafter, every field soldier, every wilderness guide has learned this truth the hard way. The lubricant industry has known it for decades, and they have never once mentioned what the solution actually is. The solution has been in laboratory reports, NASA mission documents, and military technical manuals since the 1960s. Its name is tungsten disulfide. Its chemical formula is WS2, and the numbers behind it are so far outside normal experience that most people assume they are a misprint. The dynamic friction coefficient of WS2 is 0.03. To understand what that number means, compare it to what you already know. Teflon, the material on your non-stick pan, has a friction coefficient of around 0.04. Motor oil sits between 0.05 and 0.1. WD-40 starts near 0.1 and climbs rapidly as it collects contamination. WS2 at 0.03 is not marginally better than these materials. It is in a different category entirely. It is the lowest friction coefficient of any known solid lubricant on Earth. That is not a marketing claim. That is a measurement published across peer-reviewed materials, science literature spanning 60 years. WS2 remains fully functional from -273 degrees Celsius within a fraction of absolute zero, all the way up to 650 degrees Celsius. It withstands pressures of 300,000 psi without structural failure. There is no wilderness environment, no climate extreme, no mechanical load, no operational condition on the surface of this planet that exceeds what WS2 handles without effort. In 1969, NASA faced a problem no engineer had ever solved before. In the vacuum of space, oil-based lubricants outgas. They evaporate instantly and vanish. Greases freeze near absolute zero and shatter like glass. Wet lubricants attract microparticles and build contamination layers that destroy precision tolerances within days. NASA needed something that was not wet, something that bonded to metal at the molecular level and stayed there regardless of temperature, pressure, or vacuum. The answer was tungsten disulfide. WS2 is a lamellar compound. Its atoms are arranged in flat layers that slide over one another with almost no resistance, like a deck of perfectly smooth cards slipping apart under the slightest pressure. When the powder is applied to a metal surface and burnished in, individual WS2 molecules fill the microscopic valleys and peaks of the metal grain structure. They do not sit on top of the surface. They become part of it. Once that bond forms, it does not break. Rain cannot wash it away. Cold cannot thicken it. Heat cannot thin it. Dust cannot contaminate it because there is no wet surface for contamination to adhere to. NASA trusted this material on Mars. When the Mars rovers were designed, engineers knew one absolute rule. If a moving part failed on Mars, there was no repair mission coming. The entire multi-billion-dollar mission ends the moment one bearing seizes, one gear grinds, one joint locks under Martian dust. NASA chose WS2 as the primary solution for the most unforgiving mechanical environment a vehicle has ever operated in. No wet lubricant has ever been trusted to do what WS2 does on those missions, not one. And while NASA was trusting it with spacecraft, the military was trusting it with the mechanisms that keep soldiers alive. Precision long-range shooters discovered WS2 through weapons testing reports. A rifle barrel treated with WS2 shows dramatic reductions in carbon fouling. In standard barrels, Carbon builds inside the rifling grooves with each shot, degrading accuracy over hundreds of rounds. In WS2 treated barrels, the same carbon has almost nothing to adhere to. Cleaning intervals stretch from every 100 rounds to over 1,000. In the field, where cleaning supplies are scarce, that difference is not a convenience, it is a tactical advantage. Competitive shooters applying WS2 to trigger mechanisms describe the result in one word consistently: glass. The trigger breaks like glass. Every moving part moves exactly as designed, without the variability that wet lubricants introduce when they thicken in cold or thin in heat. Every knife maker and bushcraft tool builder who has discovered WS2 reports the same experience. The pivot point of a folding blade opens with pressure so light it feels factory engineered, not with the drag of a pivot that has collected dust and old oil into grinding paste. With the clean, consistent arc of a mechanism that has been properly maintained at the molecular level. For axes and fixed blades, the treatment reduces the microabrasion that dulls an edge from the inside out when a blade moves against a sheath. The edge stays sharper longer because the steel is no longer grinding itself away every time it moves. Here is where the numbers should make you step back and do the math. The average gear-focused person spends between $30 and $80 per year on lubricants, WD-40, gun oil, blade oil, hinge spray. Each product is purchased and repurchased in a cycle that never ends because each product depletes and fails in exactly the conditions where it is needed most. A single 15-gram container of WS2 powder costs between $8 and $15. One container is enough to treat every moving metal surface in your entire gear inventory, every knife pivot, every axe head, every rifle component, every hinge, buckle, and pulley you own. The treatment lasts not for months, but for years of active field use. No reapplication schedule, no depletion curve, no wet surface to rinse away in rain or freeze in cold. One purchase. Done. You cannot build a $166 billion lubricant industry on a product that costs $10 and lasts the lifetime of the tool it protects. You cannot generate quarterly revenue from something that needs no replacement. You cannot patent tungsten disulfide. It is a mineral compound that has existed in the Earth's crust for billions of years. You cannot create a proprietary version because the chemistry is settled, published, and free. And you cannot market against it using performance claims because its numbers end the conversation before it begins. So the industry does what it has always done with things it cannot compete against. It ignores them. It crowds the shelf space with familiar packaging. It writes recommendation guides that never mention the alternative exists. And WS2 sits in a small listing on a materials science supplier website purchased almost exclusively by aerospace engineers, competitive shooters, and the small percentage of gear people who found it the hard way, by reading the documents that were never meant for general distribution. I need to be honest about one limitation. WS2 does not add corrosion protection. In environments with saltwater or direct moisture exposure, you will still want a light rust barrier coat before or after applying WS2. For manual tools, field equipment, weapons, and the mechanical systems a survivalist actually works with, this limitation almost never applies. For the gear you carry into the wilderness, the gear you depend on when repair is not an option, WS2 has no competition. Here is exactly what to do. Search for tungsten disulfide powder, WS2, on Amazon or any industrial supplier. Buy the dry powder form, not a spray. Spray formulations add carrier fluids that undercut the performance of the pure compound. Look for particle size listed at 0.6 microns or smaller. Finer particles penetrate deeper into the metal grain structure. Before application, clean the metal surface with isopropyl alcohol or acetone. Remove every trace of existing oil and contamination. The metal must be completely dry. Take a small amount of powder on a microfiber cloth or cotton patch. Apply firm circular pressure to the metal surface. You are not wiping the powder on, you are pressing it in. This is called burnishing. Work in sections. The metal will show a faint dark grey tint as the WS2 bonds into the grain. When the surface feels glassy under your fingertip and the color has shifted slightly, the bonding is complete. Blow away any loose excess powder. Done. Total time per knife, under 5 minutes. Total time for a complete field kit, 1 afternoon. Total cost, $10 to $15 once. Your knife will open on a cold morning at -15 with the same pressure it required in your heated workshop. Your rifle bolt will cycle under field contamination with the same action it had clean at the range. Every piece of gear you treat will perform at the top of its design specification for the rest of the time you own it. NASA figured this out because they had no choice. The military adopted it because performance in field conditions is the only standard that matters. The engineers who build the most demanding mechanical systems on Earth use it because the alternative is failure at the worst possible moment. And the lubricant industry has spent 40 years making sure the rest of us kept buying the bottle that runs dry. The powder is on a shelf right now. The application takes 5 minutes. The result is a piece of gear that will never let friction be the reason it fails you. This knowledge did not disappear. It was buried under 60 years of marketing from an industry that depends on your equipment running out. Now you know it. If this vault opened something for you, subscribe and share it. Every share preserves what they spent billions to keep invisible. The next vault opens soon. What is inside is even heavier than this.